Hi, I'm Mark Hardwick, Director of Software Engineering at PyTop. As many of you know, Raspberry Pi has enjoyed a phenomenal success with makers all over the world. I think today they've sold over 30 million units. PyTop's mission is to make Raspberry Pi even better when used in the classroom. To do this, we've created a robust, modular, easy to use ecosystem of products that allow teachers to teach while avoiding common problems that teachers encounter when using Raspberry Pi in the classroom, particularly with the fragile nature of wiring and the time spent doing all of that with bare bones versions of the Raspberry Pi. The Pi Top 4 is at the heart of this ecosystem, and it's an amazing device. You can build a wide range of projects around it, including a Mars-like rover that uses our motors and motions kit coming out soon. Also, you can build musical instruments, a weather station, and more. In fact, one of our schools is using it to replicate the International Space Station. When used within a project build, you can connect it via any computer, whether it's a Mac, Windows, or Chromebook. If you prefer, you can purchase the PyTop with its integrated keyboard and touch-sensitive screen that turns the PyTop 4 into a full functioning portable computer for homework or browsing the internet and doing experiments with the Foundation Kit. If you have a screen and keyboard available, you can use it with your PyTop 4 as a mini desktop. No matter how you connect, the full range of free Linux-based software is available to you, which includes word processing, graphics, CAD, and of course all the PyTop's learning challenges which are available within Further. The PyTop 4 turns the Raspberry Pi into a mini computer that supports learning easily. This is an informal video that I put together to introduce you to Further, which is PyTop's learning network. I'm going to take the time to run through the features as it's live today and then take a look at things in the roadmap for the future. Further is an essential part of the PyTop ecosystem. It provides learning challenges that use the Foundation Kit and the Motors and Motion Kit and future project kits, all of which work seamlessly with the PyTop 4. Our challenges are structured around our Assemble, Tinker, Play, Share learning model. This is a staged model that we use to build student confidence with making and coding in a series of easy progressions. Our content is also aligned with Raspberry Pi's curriculum, which means schools can make use of the wide range of Raspberry Pi resources while enjoying the ease of use benefits of PyTop. Currently, our challenge is focused on builder and developer stages of the PyTop curriculum, and then they'll expand to the creator and maker over the course of the year. So let's take a look at Further. So when you launch Further, you arrive at the challenges that are available for the PyTop 3 as well as the PyTop 4. When teachers go into the login, they'll find they can log in via Clever or Google Classroom. When using Clever or Google Classroom, teachers will find that they can synchronize their classes and related students and avoid doing any manual setups. Logging in as a teacher, you'll see 4 tabs at the top. And by the way, these are only visible if you have the teacher role when you log in. They include Explore Challenges, which are created by PyTop, and they again follow the Assemble, Tinker, and Play, Share learning model. The central idea with Explore Challenges is the teacher can use them directly or customize them to their own needs. The My Challenges tab is where you can create challenges from scratch or continue customizing challenges that you've taken from the public area under the Explore Challenges tab. This allows teachers to edit the challenge by adding or removing code or features of that challenge that might change due to grade level of the students or the type of equipment being used. The next tab is Classes. Here you'll find your classes that are working with Further. Then the last of the 4 tabs, Students. This is where you'll manage your students' information. Now let's take a look at one of the challenges, the PyTop 4 Timer Challenge. So as a teacher, I have access to the challenge. I can read the challenge, and if it's one of my challenges, I can edit the challenge. And I can work with multiple collaborators as well. Within the challenges, I can associate them with standards. There's a wide range of standards listed from which to choose. And as you can see, it's an extensive list. Teachers can upload teacher resources. There are none in this challenge at the moment, but nonetheless, this resource is available for best practices, lesson plans, and the like. Challenges start with a list of parts with an image that depicts what each part is and the number of parts required. Moving on to assembly, it takes you through each component and how they connect to the foundation plate on the PyTop 4. This is a very important part of Further and the PyTop ecosystem. Comparing this modularity of plugging into the foundation plate versus a breadboard with a bare bones Raspberry Pi, well, there is no comparison. It's easier, safer, and there's no chance of shorting or damaging components or the Raspberry Pi board itself. Not to mention that it eliminates the possibility of getting the wiring wrong and the associated troubleshooting, which takes away from valuable instruction time. Gives you all the pleasure of the physical making without the pain of the typical problems. Within the challenges are tasks. The teacher can direct students to provide different types of evidence that they are working with and the progress that they have made along with that. And understanding the section and the work done is important. Tasks also include text, image, and the ability to attach a file. So with task, it not only helps the teacher assess the student, but it tells how much progress the student is making through the challenges. Another important feature of Further is code blocks. Code blocks are color-coded, which show language and keywords within Python. The code is numbered as you'd expect in Python, and you can copy the code to paste by simply clicking the clipboard icon. One key benefit within Further is that we have integrated a developer environment within it. This allows you to code and view output from the code and provide input. You make an IP selection, put in the IP address, and then simply click Run and enter the number of minutes associated with the code. You can stop it to change or modify the code on the fly. After you change or modify the code, you can set the time and click on Run and see the results on the fly. There's a live printout of the console at the bottom, as you can see here in a moment. This is a very powerful tool to have while in the classroom, being able to cut, paste, edit in this environment flexibly. And there's no need to cut and paste content between Further and the IDE. You simply enter the code and run it and get the results back right away. Challenges are moderately long, but they can be broken up into sections. At the moment, we are in the Assemble section. As we scroll up, we can find the Tinker section. And then we can find the Play section, and so on. At the bottom of each challenge, there are links to other resources, libraries that might be helpful, as well as tutorials that students might find useful as they work through the challenge. After completing a challenge, a teacher will want to assign it to a class. In this example, let's assign the selection Python is fun to a class. This is a class of 1, and certainly you'd have more than that. Here you'll see the challenge is linked to the class. And we can click on the View Responses to see what students are saying. Let's now log in as a student so we can see their view within Further. Here you'll see only 2 tabs, whereas the teacher view had 4, as you might recall. The 2 tabs are Explore Challenges and Classes. A student can explore new challenges or click on classes they are already enrolled in. Clicking on the class, Python is Fun, we can see the challenges that are assigned to the student. And the student can create a submission, as well as indicate that they are working alone. And then add the submission. Then they see the challenge and they can start working through it. As the student scrolls through the challenge, they can see the first task as assigned by the teacher. And here we're going to use a screenshot to upload. And a student can write a comment to go along with the image. The student, much like the teacher, can take code and copy it and paste it, select the device, and run the code, all within Further. Again, one of the more powerful features of having this developer environment embedded in the application. Now let's take a look at some of the new features that we'll be releasing over the next few months. First will be what we're calling foundation tutorials. These will help introduce teachers and students to Further in a very elegant way to the language of Further, as well as the components of the Foundation Kit itself. Here's how it will work. Clicking on the LED lights tutorial, it'll take you step by step through a guide on how to connect the foundation plate and associated cables and LED lights. Then, writing some code that turns the LED lights on, and then connect the PyTop 4. From there, you can tinker with the code to make the LED lights behave differently by changing the values, and click play to run those changes. Once completed, you'll receive a check in the upper corner of the tutorial indicating that it's been completed. The teacher or student can go from there and work through all the tutorials. Next, we're working to improve the student management within Further. This will provide a deeper insight into how the student is progressing and show where the students are and whether or not there's anyone who's struggling. It will also include teacher assessment tools, which will be valuable in determining student success. Additionally, we wanted to provide integrated messaging within Further that allows teachers to respond to comments made by students within challenges. This helps teachers keep track of student work and their ongoing progress. A valuable tool. Also, providing access to block coding functions so that teachers can switch between block and text coding easily, which is a nice scaffolding from one form to the next. Lastly, we're integrating a glossary of terms that helps teachers and students simply click on a component or subject and see its definition. Well, that's Further. Please visit us at pytop.com for more information on the amazing PyTop 4 and the Foundation Kit, and of course Further, all featured in this video. Until next time, this is Mark Hardwick with PyTop. Thanks for watching.